I've been wondering what exactly this part was. Well, I just unmounted it, and indeed it is a capacitor, and it is not grounded. One of the few in this radio that isn't. Like, for example, the 8 in here all have a common negative. Well, this one has 2 wires coming out of it, and that's because it's a coupling cap. It's used for the volume control at 0.04 microfarad. So they did have some coupling caps in here. So again, why couldn't they use one over here? I rebuilt and installed that coupling cap going to the volume control, and I figured, well, might as well check the volume control while I'm in that area. Now, according to the schematic, it should be 2 meg. Well, that's not what I got, so I decided to go ahead and pull it out, and that confirmed what I was reading while it was in the set, about 10 meg. So I thought that warranted a closer look. It's kind of interesting control. Also notice it doesn't have a part number on it like all the others do, which makes me think it might not be the original. In parts placement, they do show it as a rectangular box though. And it's got a part number, something like 24064. The wiring looked to be fairly original, so I'm not convinced either way. It's original or not original, but it's certainly measuring 10 meg. Now, it looks like this cover comes off pretty easily. I think it has snaps on the side. So, yeah, it's actually kind of loose. So let's see if we can get this off. Well, that's certainly something different. It's made by Alan Bradley, called a Bradleyometer. Patent applied for. So let's see how this action goes. Okay, so here's the shaft that couples directly to a little gear which rides against this insulating material, probably Bakelite or something similar, which goes to the wiper arm. So it actually, the wiper rotates in the opposite direction of the rotating shaft. And it rides along these. These are 2 outer contacts, and it goes to what looks like a sandwich of metal discs and I assume some type of insulating material in between. It looks pretty darn clean. So let's see what the wiper action is actually like. Analog meter works a little better for doing something like this, but we'll get by. We can watch a little bar graph down here. So go all the way to one side, and I'll go to the other side. So we got about a short on that end. As we travel, increases. What I'm looking for is any jumps or discontinuity. It looks to be increasing pretty smoothly. The meter jumps between ranges, so it's a little annoying, but basically if we keep seeing this increase across the face of the meter, that's a good thing. What's odd though is I'm halfway across. 10 meg, you'd think it'd be about 5 meg in the middle. It's only 250K, so this must, well, assuming it's not damaged, this has to be a logarithmic taper. So it must increase, and increasing really rapidly as you get towards the other end. It's 1 meg, 2 meg, so yeah, we're jumping up really fast now. 4 meg, 5, 6, 7, 8, 9, and then about 10 at the other end. Looks like exactly 10.00. So it looks clean. The action seems to be really smooth, so I guess I'll just pop this back in and see how it works out. I don't think that value's too critical. So what that does is it couples the output of the detector into this pi filter of 200 picofarad caps with an inductor in between. So it's very similar to a power supply. With 2 caps and a choke here, 2 caps and a choke here. It's like 10 millihenry, and then that goes directly to the grid of the 37 tube. So very simple arrangement. Pretty easy to follow the action here. So coupling cap into one side of the wiper to remove DC components. Other side's grounded. We got a wiper going to a pi filter feeding the grid of the audio output tube. So the question is how critical is that value, 2 meg versus 10 meg? Well, that's going to be kind of a load on this output circuit here. But as people often say, hey, if you found a component in the device that wasn't the original value, well, if it looks like the radio is used a lot, pretty good chance it worked fairly well, otherwise they wouldn't have left it in there. The only opposite to that, or caveat to that, is if somebody gave up trying to repair it, or it didn't work all that well. That you're kind of never going to know. So these aren't quite engaging all the way like they should be. There's kind of a curve here, like I could mash this down, but I'm kind of afraid to. I don't want to damage anything. Yeah, I'll just leave it alone. It's in there pretty securely. Put a little oil in there. The surfaces around. Well, a little oil and a little grease. And then there's a similar control on the other side, which is power and tone. So which is kind of odd, and it's not like a Philco where it's a power switch and then a multi-position switch for tone. So every time you turn this on, you're going to have to find the tone that you like. You can leave the volume where you left it off last at the volume level you like, but you got to tweak the tone every time. Odd arrangement, if you ask me. Also started working on the electrolytic block. Pretty easy. Just cleaned out the mounting holes here and went off of my diagram here. The only thing you got to remember is it's not looking at it that way. It's looking at it this way. So the 8 goes up here. Just have a couple more to install and then hook up all the common grounds and use a nice heavy bus wire and run it out to this contact, which goes to ground. I don't know why I didn't notice it at first, but this does indeed have a part number on it. 24064, which matches the parts list, so perhaps this was 2 meg at some point, and it's drifted up. Each one of those discs might be carbon, similar material to the resistors, and it drifts up just like they do. I still want to try it though. I'll leave it in there. If it's the original, even more reason to try to give it a go and see how it works out. Here's a look at the rebuilt electrolytic block. May not look too pretty, but it is sound mechanically and electrically. And it plugs into the chassis like so. It's a nice, neat way to do it. I kind of wish all the radios were built like this. Instead of having to rebuild a bunch of cans or stick capacitors or under the chassis or install terminal strips, you just stick them all right in here and you pop it into the chassis and you're done. And this goes over it, so nobody would ever know. And if you want to service it, hey, you just pop this off. Remember, these are held on by screws. These are actually not riveted together or anything. It's just the screw just goes through both pieces and not only holds this down firmly, but also holds the top on. So nice and neat. And obviously, I repainted this can, and I also repainted this guy, so that will go in like that, and that is where the one lone capacitor goes, and I get to install this guy and the driver transformer. For now though, I'm going to tack those in below the chassis and make sure this thing actually works before I bother to stick it inside that can. So now I need to do work underneath the chassis because a lot of work was done around that socket in the past and I need to clean it and repair it. Here's a look at what I was talking about. So this mess needs to all be rewired up. Some of these lugs don't even have any wires going to them anymore. Some all the old repairs where wires were just cut, new parts stuck in place. So I gotta figure out what these should go to and double check that the wires that are attached are correct. Here is the last of the capacitor blocks to be rebuilt. It's got a couple 0.2 microfarad caps in there. Started wiring in the driver transformer. Just got enough room to squeeze in the output transformer over here to try it out. And just a few other stray resistors to be replaced. And then, well, I guess it'll be time to try powering this up. Just reinstalled that rebuilt cap. Need to wire back in. And right now I'm checking some mica caps down in this area, and they're all checking fine. So capacitance is just about dead on. And no leakage. So that one's about 4,000 picofarad. These two guys are about 100, just as they should be. One more down in there, one more in there. But I think they're all going to be all fine. Let's see. The reason I took these out of the way was to get at some resistors that were really kind of tucked down under in there. So 1, 2, 3 resistors to replace. And boy, getting really close, What do you think the chances are that this will actually do something the first time I power it up? Well, we shall soon see.